Have you ever stopped to consider the most profound mystery in the entire universe? A mystery that is not located billions of light years away in the deep darkness of intergalactic space, nor hidden inside the event horizon of a supermassive black hole, but is instead right here, right now, reading these words and hearing this voice. I am talking about you, not your physical body, not the hands that hold your device, nor the eyes that scan the screen, but the invisible, weightless, and silent observer that exists behind those eyes. I am talking about the sensation of being, the feeling of I am. We spend our lives looking outward, building telescopes to peer into the dawn of time and microscopes to unlock the secrets of the cell. Yet, the very tool we use to do the looking, the human mind, remains an enigma so deep that science has not even begun to scratch the surface of what it actually is. Consider for a moment the sheer improbability of your own awareness. According to the standard laws of physics and chemistry, you are a collection of atoms, roughly 7 billion of them, forged in the hearts of long-dead stars, now arranged in a very specific pattern that walks, talks, and thinks. But atoms themselves are not alive. A carbon atom in your brain is no different from a carbon atom in a lump of coal or a diamond. It has no hopes, no dreams, no sensation of the color red or the smell of rain. And yet, when you arrange enough of them in the specific architecture of the human brain, something miraculous happens. The lights turn on. The universe wakes up. Suddenly, there is an inside to the world. There is a you who experiences the flow of time, the warmth of sunlight, and the ache of loneliness. How does this happen? How does dead matter give rise to the living mind? This is the question that keeps the most brilliant physicists, neuroscientists, and philosophers awake at night, staring into the dark. It is called the hard problem of consciousness, and for decades, the prevailing scientific view has been that the brain is simply a wet, squishy computer, a biological machine that processes information through electrical spikes and chemical signals. But there is a new theory rising from the borderlands between neuroscience and quantum physics, a theory so radical and so mind-bending that it challenges everything we thought we knew about who we are and what reality is. It suggests that the brain is not just a computer of flesh and blood, but something far more exotic. It proposes that the seat of your soul, the very core of your conscious experience, is a quantum process, a delicate dance of subatomic particles shimmering in a state of existence that defies the laws of the everyday world. If you enjoy exploring the deepest questions of existence and journeying into the furthest reaches of scientific mystery, please take a moment to subscribe to the channel Theodore, the Researcher, and like this video. It helps us continue this quiet journey together, bringing the wonders of the cosmos and the mysteries of the mind directly to you, creating a space for contemplation in a noisy world. Your support allows us to keep asking the questions that matter most. Now, let us settle into the silence and begin our exploration of this theory that terrifies scientists not because it is dangerous, but because it suggests that the universe is far stranger and more beautiful than we ever dared to imagine. To understand why this idea is so revolutionary, we must first look at the standard story science tells us about the brain. For the last century, the dominant metaphor for the brain has been the computer. In this view, your brain is hardware and your mind is software. The hardware consists of about 86 billion neurons, specialized cells that look like tiny trees with long branching cables. These neurons are connected to one another at junctions called synapses. When a neuron fires, It sends an electrical pulse down its cable, releasing a burst of chemicals that cross the gap to the next neuron, either encouraging it to fire or telling it to stay quiet. It is a binary system, on or off, 1 or 0. In this classical view, everything you are, your memories of childhood, your love for your family, your fear of the dark, your understanding of this sentence, is simply the result of trillions of these little switches flipping on and off in complex patterns. It is a mechanical, deterministic view of the soul. It suggests that if we could build a computer powerful enough and program it with the right algorithms, it would eventually wake up and become conscious. It implies that you are, in essence, a very complex calculator. But there are cracks in this foundation. There are things about the human mind that simply do not fit the computer model. Computers are algorithmic. They follow a set of strict rules to arrive at a conclusion. But human thought is often non-algorithmic. We have insight. We have intuition. We have the ability to understand truths that cannot be proven by following a set of logical steps, something the mathematician Kurt Gödel demonstrated was impossible for a standard logical system. Furthermore, there is the issue of the qualities of experience, what philosophers call qualia. A computer can process the wavelength of light that corresponds to the color red. It can label it red. It can react to it by stopping a self-driving car. But does the computer see red? Does it feel the redness? Does it experience the visceral sensation of color? Most scientists and philosophers would say no. A computer processes syntax, the arrangement of symbols, but it does not understand semantics, the meaning behind those symbols. So, if the brain is just a biological computer operating on classical physics, where does the feeling come from? This is where the quantum theory of consciousness enters the stage, opening a door that many scientists were afraid to even approach. Quantum mechanics is the branch of physics that describes the universe at its smallest scales, the world of atoms, electrons, and photons. And the rules of this subatomic world are completely different from the rules of the world we see around us. In our everyday reality, things have definite positions and states. A cup is either on the table or it is not. It cannot be in two places at once. But in the quantum realm, particles exist in a state of superposition, meaning they can be in multiple states or multiple locations simultaneously. An electron can be spinning clockwise and counterclockwise at the exact same time. It exists as a wave of probability, a shimmering cloud of potential, until it is measured or interacts with the environment, at which point it collapses into a single, definite state. There is also the phenomenon of entanglement, where two particles become linked in such a way that the state of one instantly affects the state of the other, no matter how far apart they are, even if they are on opposite sides of the universe. Albert Einstein called this spooky action at a distance. For a long time, physicists believed that these quantum effects could only survive in the cold, isolated vacuum of the laboratory. They thought that the brain was too warm, too wet, and too noisy for delicate quantum states to exist. They argued that any quantum coherence would be instantly destroyed by the thermal chaos of the body, just as a snowflake melts in a pot of boiling water. But in the 1990s, a Nobel Prize-winning physicist named Sir Roger Penrose and an anesthesiologist named Stuart Hameroff joined forces to propose a theory that challenged this assumption. They suggested that the brain has evolved a way to protect these delicate quantum states, to shield them from the noise, and to use them to generate the phenomenon of consciousness. Their theory is known as Orchestrated Objective Reduction, or ORC-OR. The cornerstone of this theory, lies not in the neuron itself, but deep inside it, in the tiny tube-like structures that give the cell its shape. These are called microtubules. For decades, biologists thought microtubules were just the scaffolding of the cell, a kind of structural skeleton that held everything in place and acted as a highway for transporting molecules. But Penrose and Hameroff looked closer. They saw that microtubules are crystal-like lattice structures made of proteins called tubulin. They realized that the symmetry and structure of these microtubules might make them perfect biological quantum computers. The theory proposes that inside the hollow cores of these microtubules, shielded from the noisy environment of the rest of the brain, subatomic particles can enter a state of quantum superposition. They can exist in multiple states at once, calculating and processing information in a way that no classical computer ever could. In this view, the brain is not merely a system of switches flipping on and off. It is an orchestra of quantum vibrations. The music of this orchestra, the collapse of these quantum states into definite reality, is what we experience as a moment of consciousness. Think of it this way. In the classical view, your mind is a continuous stream, like a movie film. But in the quantum view, your consciousness is a series of discrete events, tiny ripples in the fabric of space-time occurring 40 times a second or more, stitching together to create the illusion of a continuous flow. Every time a quantum state inside your microtubules collapses, a spark of awareness is born. This theory is terrifying to some because it bridges the gap between the physical and the non-physical in a way that feels almost mystical. It suggests that consciousness is not an accidental byproduct of computation, but a fundamental feature of the universe itself, deeply connected to the very geometry of space-time. When we consider the possibility that our minds are quantum phenomena, we are forced to reevaluate our connection to the cosmos. In the classical Newtonian universe, we are isolated observers, separate from the world we watch. We are ghosts in the machine, peering out through biological windows. But in the quantum universe, the observer and the observed are inextricably linked. If the processes that generate your thoughts and feelings are rooted in the same quantum mechanics that govern the birth of stars and the behavior of light, then you are not merely in the universe, you are of it in the most intimate way possible. The quantum entanglement that might be happening inside your brain suggests a level of connectivity that borders on the spiritual. It implies that the boundary between self and other might be more permeable than we think. Imagine for a moment the billions of neurons in your brain, each containing thousands of microtubules, each acting as a tiny quantum resonator. If this theory is correct, then right now, as you listen to this, there is a quantum storm raging inside your skull. But it is not a storm of chaos. It is a storm of creation. It is the universe collapsing from probability into reality, over and over again, crafting the unique, unrepeatable experience of being you. This perspective transforms the brain from a biological calculator into a quantum antenna, a device tuned to the fundamental frequencies of reality. It raises the question, if the brain is a quantum computer, what is it computing? Is it merely processing data from the eyes and ears? Or is it interacting with the information geometry of the universe itself? The resistance to this theory has been fierce. Mainstream neuroscience has held on to the computational model for decades. The idea that we need quantum mechanics, the most difficult and mysterious branch of physics, to explain the mind, which is the most difficult and mysterious phenomenon in biology, was seen by many as simply piling one mystery on top of another. Critics argued that the brain is simply too hot and wet. They calculated that quantum states would decohere or fall apart in femtoseconds, far too quickly to have any impact on the slow, millisecond timescales of neuron firing. For years, Penrose and Hameroff were dismissed as dreamers, their theory relegated to the fringe. But science is a journey that never ends, and the tides are beginning to turn. Recent discoveries in the field of quantum biology have shown that nature is far more clever than we gave it credit for. We have found that plants use quantum coherence to harvest sunlight with near-perfect efficiency during photosynthesis. We have discovered that migrating birds use quantum entanglement in their eyes to see the Earth's magnetic field and navigate across thousands of miles of open ocean. If a blade of grass and a robin can utilize the strange powers of the quantum realm, is it so impossible that the human brain, the most complex object in the known universe, has evolved to do the same? New experiments are beginning to hint that microtubules can indeed maintain quantum resonances for much longer than previously thought possible. The warm, wet, and noisy argument is slowly crumbling in the face of new evidence, suggesting that biology has found a way to master the quantum world. As we stand on the precipice of this new understanding, we must approach it with humility. We are like children walking along the shore of a vast ocean, picking up pebbles and shells, while the great truth of the deep water lies undiscovered before us. The idea that consciousness is a quantum computer does not solve the mystery of existence. It deepens it. It takes the familiar sensation of me and connects it to the weird, non-local, time-bending reality of the subatomic. It suggests that the stillness you feel when you close your eyes is not an emptiness, but a fullness, a connection to the underlying quantum field that permeates all of space. It hints that the silence of the mind is the same as the silence of the void, pregnant with infinite possibility. If this theory holds true, then every thought you think, every dream you dream, is a ripple in the quantum fabric of the universe. You are not a fleeting accident of chemistry. You are a participant in the ongoing creation of reality. The terror that scientists feel is the terror of the sublime, the realization that the universe is not a dead machine, but a vibrant, interconnected web of potential, and that our minds are the nodes where the universe becomes aware of itself. As we drift deeper into this series, we will explore the specific mechanisms, the evidence, and the profound implications of this theory. We will journey into the microscopic architecture of the neuron, travel back to the origins of life, and speculate on what this means for the future of artificial intelligence and the destiny of the human soul. But for now, let us simply rest in the wonder of the possibility. Let us appreciate the mystery that we are. You are a quantum observer. You are a vessel of stardust and probability. And the journey into the nature of your own mind is just beginning. This exploration challenges us to rethink the very nature of death as well. If consciousness is tied to the quantum structure of space-time, does it simply vanish when the biological body ceases to function? Or does the quantum information that comprises your self return to the larger field like a drop of water returning to the ocean? These are questions that venture beyond the current limits of science, yet they are questions that the quantum mind theory allows us to ask with a new kind of seriousness. We are moving away from a materialist view that sees the mind as a temporary illusion, toward a view that sees consciousness as a fundamental, perhaps even eternal, component of the cosmos. It is a shift from a universe of dead matter to a universe of living light. It is a shift that restores a sense of sacredness to the act of being alive. So, as we close this first chapter of our investigation, take a moment to feel the weight of your own existence. Feel the miracle of your breath. Feel the impossible fact that you are here, aware and understanding. In a cosmos of black holes and burning stars, of expanding voids and colliding galaxies, the most intricate and mysterious object is the one sitting in your chair. The universe has spent 13.8 billion years evolving to the point where it can look in the mirror, and that mirror is you. To understand the magnitude of the shift that the quantum mind theory proposes, we must first walk through the grand cathedral of the current scientific orthodoxy. We must understand the story that has been told about us for the last 100 years, a story that is at once incredibly detailed and, many would argue, profoundly incomplete. It is the story of the mechanical mind. Imagine for a moment that we could shrink ourselves down to the size of a single photon of light and enter the human brain through the pupil of the eye. As we pass through the optic nerve, we find ourselves in a biological forest of unimaginable density. This is the cerebral cortex, the wrinkled outer layer of the brain, where most of what we call thinking takes place. Around us, towering like ancient trees, are the neurons. There are forests upon forests of them, stretching out in every direction, their branches intertwining in a canopy so thick it blots out the void. In the standard scientific model, this forest is a machine. It is a biological computer of staggering complexity, but a computer nonetheless. The prevailing view, known as computationalism, holds that everything you are, your personality, your memories, your fears, and your deepest loves, is fundamentally a software program running on this wet, organic hardware. It suggests that if we could map every single neuron and every single connection, known as the connectomy, and then simulate that map on a sufficiently powerful silicon chip, that chip would become you. It would wake up. It would wonder where its body went. It would feel the phantom sensation of a breath it no longer needs to take. This idea is seductive because it promises a kind of immortality. If you are just code, then you can be backed up, copied, and transferred. But it also implies something that many find deeply unsettling, that you are essentially an algorithm, a sequence of mathematical operations with no true agency, no true ghost in the machine. If you find yourself questioning the nature of your own reality and enjoying this deep dive into the unknown, please remember to subscribe to the channel Theodore, the researcher, and like this video. It is a small gesture that helps us continue to produce these quiet explorations of the biggest questions in the universe. Your support allows us to keep the lights on in this library of mysteries, inviting more travelers to join us in the contemplation of the cosmos. Let us return to the forest of the mind. The classical view of the brain is built on the physics of the 19th century. It sees the neuron as a classical object, like a billiard ball or a telegraph wire. It operates on the principles of electricity and chemistry that we understand very well. A signal comes in, a threshold is crossed, and the neuron fires. It is a deterministic chain reaction, cause and effect, ticking forward like a clock. In this view, consciousness is what is called an emergent property. Just as wetness is not a property of a single water molecule, but emerges when you put trillions of them together, consciousness is thought to emerge when you put billions of neurons together in a complex enough network. It is a beautiful idea, elegant in its simplicity. It suggests that complexity itself is the key. If you build a pile of sand high enough, it just becomes a hill. But if you build a network of switches complex enough, the materialist view says it becomes a mind, Yet, as we look closer at this forest, we begin to see the shadows where this theory fails to shine a light. There is a gap in the logic, a chasm so wide that philosophers have given it a name: the explanatory gap. You see, we can explain how the brain processes information. We can trace the electrical signal from the retina to the visual cortex. We can see how the brain distinguishes a vertical line from a horizontal one. We can even see how it categorizes that shape as apple. But nowhere in that chain of electrical pulses do we find the redness of the apple. We find voltage changes. We find neurotransmitters moving across synaptic clefts. We find calcium ions rushing into cells. But we do not find the experience. We do not find the sensation of color, the tartness of the taste, the crunch of the bite. These subjective experiences are what philosophers call qualia, and they are the ghosts that haunt the machine. The computational model asks us to believe that if we perform enough calculations, the calculations themselves will start to feel. But does a calculator feel satisfied when it solves an equation? Does a thermostat feel cold when the temperature drops? Most of us would intuitively say no. These machines process data, but they do not have an inner life. Why, then, should a brain be any different just because it is made of meat instead of silicon? This is where the standard model hits a hard wall. It is possible to imagine a creature that looks exactly like a human, acts exactly like a human, and speaks exactly like a human, but has absolutely no inner consciousness. Philosophers call this a philosophical zombie. If you stuck a pin in its arm, it would say, ouch, and pull away, because its programming tells it to avoid damage. But it would feel no pain. It would simply be executing a subroutine. If the brain is just a computer, why aren't we all zombies? Why did evolution go to the trouble of evolving this rich, vibrant, painful, and beautiful inner world, when a simple, unfeeling automaton would have survived just as well? The fact that we feel, the fact that we suffer and rejoice, suggests that there is something else going on, something that mere computation cannot explain. This is the crack in the door through which the quantum theory of consciousness steps. It suggests that the emergence theory is a hand wave, a magic trick used to hide our ignorance. It proposes that you cannot get consciousness out of dead matter just by arranging it in a complex shape, any more than you can get nuclear fusion out of a pile of rocks just by stacking them high enough. You need a fundamental change in state. You need to tap into a different kind of physics. Consider the neuron again. For a century, we have treated it as a simple switch. But biology is rarely simple. If we look deeper, past the cell membrane, past the nucleus, into the very scaffolding of the cell, we find the microtubules. These are not just structural supports. They are incredibly complex lattice structures, cylinders made of millions of protein subunits, arranged in a perfect Fibonacci spiral. They are vibrating, organizing, and interacting in ways that we are only just beginning to understand. The classical model ignores these structures, treating the interior of the neuron as a bag of salty water. But the quantum model asks, what if the real processing is happening down here at the nanoscale? What if the neuron is not the bit, but the entire computer? And what if the brain is not a network of switches, but a network of quantum resonators, a fractal hierarchy of information processing that goes down to the level of the fabric of space-time itself? This shifts the perspective from a brain that creates consciousness to a brain that accesses or orchestrates consciousness. It implies that the qualities of experience, the redness of red, the feeling of pain, might be fundamental properties of the universe, woven into the very geometry of existence at the Planck scale, the smallest possible scale of reality. In this view, the microtubules act as a bridge. They are the interface where the classical world of neurons and chemical signals meets the quantum world of superposition and non-locality. They are the keys that unlock the door between the physics of the dead and the experience of the living. The implications of this are staggering. If consciousness is a quantum process, then it is not bound by the classical constraints of space and time in the way we thought. Quantum particles can be entangled across vast distances. They can tunnel through barriers that should be impassable. They can exist in states that defy the logic of A and B. If your mind is a quantum phenomenon, then the isolation you feel as an individual might be an illusion. You might be much more deeply connected to the cosmos than your eyes tell you. The classical view leaves us alone in a universe of indifference, accidental tourists in a machine that does not know we are here. The quantum view suggests we are woven into the tapestry, that our observation, our feeling, and our being are intrinsic to the way the universe unfolds. It is a terrifying thought for scientists because it breaks the clean, deterministic rules they have spent centuries building. It introduces uncertainty, spontaneity, and a kind of deep mystery back into the heart of the machine. It threatens to turn the universe from a clockwork mechanism back into a living organism. But for those of us who look at the stars and feel a sense of belonging, for those of us who have felt that the mind is more than just a calculator, this theory offers a strange kind of hope. It validates the intuition that there is more to reality than what can be measured with a ruler or timed with a stopwatch. As we continue to explore this theory, we must be careful not to fall into the trap of thinking that quantum means magic. It does not. Quantum mechanics is a rigorous mathematical science. It makes precise predictions that have been verified by experiments to an astonishing degree of accuracy. The lasers that read your discs, the transistors in your phone, the MRI machines in hospitals, all of these technologies rely on the fact that quantum mechanics is true. The question is not whether quantum mechanics is real. The question is whether biology uses it. And this is where the battleground lies. For a long time, the dogma was that biological systems were too wet and warm for quantum effects to survive. Quantum states are incredibly fragile. A single interaction with a wayward heat molecule can cause decoherence, collapsing the state and destroying the magic. Critics argued that the brain, sitting at 37 degrees Celsius, is a chaotic storm of thermal noise. They said trying to build a quantum computer in the brain would be like trying to build an ice sculpture in the middle of a blast furnace. It simply shouldn't work. But nature has had 4 billion years of research and development time. Nature has solved problems that human engineers have not even begun to address. And as we look closer at the machinery of life, we are finding that life does not just avoid quantum mechanics, it dances with it. We have seen quantum efficiency in the photosynthesis of bacteria. We have seen quantum tunneling in the enzymes that digest our food. We have seen quantum entanglement in the navigation of birds. Is it really so far-fetched to think that evolution, the greatest innovator of all, would have found a way to harness the most powerful computational system in the universe, quantum computing, to build its masterpiece, the human mind? Perhaps the brain has evolved specific mechanisms, biological shields, that protect the microtubules from the thermal noise, creating quiet, coherent islands of quantum calm amidst the storm of neural activity. This is the heart of the Penrose-Hameroff theory, that the brain is a biological quantum computer that has solved the problem of decoherence. If this is true, then we are not just biological robots. We are something else entirely. We are entities that straddle two worlds, with one foot in the solid, deterministic world of matter and the other in the shimmering, probabilistic world of the quantum. We are the place where the possible becomes the actual. This chapter of our story leaves us with a profound question. If the standard model is wrong, if the brain is not just a classical computer, then what are we? The zombie argument shows us the limits of the machine metaphor. It shows us that you can have intelligence without consciousness. You can have processing without feeling. But we do feel. The pain of a heartbreak is real. The awe of a sunset is real. These are not data points. They are lived realities. The quantum mind theory attempts to rescue these realities from the trash heap of scientific anomalies. It tries to give them a physical home, not in the firing of neurons, but in the collapse of the quantum wave function itself. It suggests that every moment of awareness is a tiny, distinct event in the structure of the universe, a bing of existence that occurs when the quantum possibilities resolve into a single choice. And if this is happening 40 times a second or 100 times a second, then our lives are a symphony of these moments, a continuous creation of reality played out on the instrument of the brain. The terror of the scientist is the wonder of the mystic. It is the realization that we are far more mysterious than we have been led to believe. In the next part of our journey, we will descend into the microscopic world to meet the microtubules face to face, to see the crystal lattices that might be the cradle of your soul, and to understand how a tube of protein might hold the secret to the universe's greatest riddle. To truly grasp the radical nature of the theory that consciousness is a quantum phenomenon, we must leave the familiar world of human interaction and descend into a landscape so alien and so intricate that it rivals the complexity of any galaxy in the cosmos. We must shrink ourselves down past the size of a neuron, past the synapse, and enter the interior of the cell itself. For decades, biology has taught us to view the cell as a bag of watery fluid, a chemical factory where genes are the blueprints and proteins are the workers. In this view, the neuron is simply a container for the electrical signals that pass along its membrane. But what if the container is actually the computer? What if the true miracle of intelligence lies not in the connections between cells, but within the architectural geometry of the cells themselves? This brings us to the most overlooked and perhaps the most important structure in all of biology, the cytoskeleton. If you were to peer inside a living neuron with eyes capable of seeing the nanoscale, you would not see a soup of random chemicals. You would see a rigid, highly organized and dynamic scaffolding. You would see a lattice of protein filaments stretching from the nucleus to the synaptic terminals, giving the cell its shape and coherence. This is the cytoskeleton, and for a long time, scientists believed its only purpose was structural, like the steel girders of a skyscraper. They thought it was simply the bones of the cell. But Stuart Hameroff, the anesthesiologist, who co-authored the quantum mind theory with Sir Roger Penrose, asked a simple yet devastating question that challenged this assumption. If the cytoskeleton is just a skeleton, how do we explain the paramecium? Consider the paramecium. It is a single-celled organism that lives in pond water. It is microscopic, ancient, and by our standards, incredibly simple. It has no brain. It has no neurons. It has no synapses. It has no nervous system whatsoever. And yet, the paramecium is capable of complex behavior. It swims. It hunts for food. It avoids predators. It finds mates. And it can even learn from experience. If you put a paramecium in a glass tube, it will figure out how to escape. How does it do this? How does a creature with 0 neurons process information, make decisions, and navigate its world? The answer lies in its cytoskeleton. The paramecium is packed with microtubules, the same cylindrical protein structures found in your brain. These microtubules act as its nervous system, its brain, and its legs all at once. They process sensory input from the water and coordinate the rhythmic beating of the tiny hairs, called cilia, that allow it to swim. If a single-celled organism can use its microtubules to think and act, why would the neurons in the human brain, which are arguably the most specialized and evolved cells in the history of life, use them only as passive coat hangers? It seemed illogical to Hameroff that nature would abandon such a powerful information processing system just because it invented neurons. Instead, he proposed that neurons are not simple switches, but are actually supercomputers containing billions of these microtubule processors. This idea shifts the seat of consciousness from the network of cells to the interior of the cell, increasing the complexity of the brain's computing power by a factor of 1 trillion. If you are finding yourself captivated by this descent into the microscopic mysteries of the mind and want to support our quest to uncover the hidden truths of our reality, please consider subscribing to the channel Theodore the Researcher and liking this video. It is a simple act that helps us build a community of curious souls dedicated to exploring the wonders of science and the depths of the human experience. Your support ensures that we can continue to bring these quiet, contemplative journeys to you. Now, let us look closer at the microtubule itself, for it is here that the quantum magic is said to happen. A microtubule is a hollow cylinder, a tiny tube about 25 nanometers in diameter. It is constructed from peanut-shaped proteins called tubulin. These tubulin proteins do not just stack together randomly. They arrange themselves in a beautiful mathematical lattice. If you unroll the tube, you see a specific pattern, a geometry that follows the famous Fibonacci sequence, the same mathematical code that governs the spiraling of a sunflower's seeds and the shape of a galaxy's arms. This connection to the deep geometry of the universe is our first hint that something profound is happening here. In the classical view, these tubulin proteins are static bricks. But in the quantum view proposed by Penrose and Hameroff, they are qubits, quantum bits. The theory suggests that each tubulin protein can exist in 2 states simultaneously, a superposition of shapes or locations. Imagine a light switch that is both on and off at the same time. Now imagine 1 billion of these switches inside a single neuron, all entangled with one another, all vibrating in perfect unison. This is not a mechanical computation. It is a quantum coherence. It is a state of matter where individual identity is lost and the system acts as a single unified wave function. This brings us to the concept of orchestration. One of the biggest criticisms of quantum biology is the problem of noise. How can a delicate quantum state survive in the warm, busy environment of the brain without collapsing into chaos? The OR theory proposes that the microtubules act as biological isolation chambers. The structure of the tube, combined with the ordered water molecules that surround it and a special gel-like state of the cytoplasm, shields the quantum states from the thermal noise of the outside world. It creates a decoherence-free subspace, a quiet zone where the quantum dance can continue uninterrupted. But it is not enough just to protect the state. The brain must also control it. This is where the orchestrated part of the name comes from. The theory suggests that biological feedback loops, proteins that bind to the microtubules, and the geometry of the lattice itself orchestrate the quantum vibrations. They tune the instrument. They guide the quantum wave function as it evolves, steering the computation toward a meaningful result. And then, at a specific moment, determined by the laws of quantum gravity, the wave function collapses. The superposition resolves into a single, definite state. This collapse is not just a mathematical curiosity. It is a moment of conscious experience. It is a spark of now. The frequency of these collapses determines the texture of our reality. Penrose and Hameroff calculate that for a human brain, these collapses happen roughly 40 times per second, which corresponds to the gamma waves we measure in the brain during moments of high focus and meditation. This suggests that consciousness is not a continuous fluid, but a cinematic reel of discrete quantum events, ticking by so fast that they blur into a feeling of continuity. But, for a distinct moment, in the silence between the ticks, the brain is in a state of pure quantum potentiality. In that state, it is not causally determined by the past. It is suspended in a realm of infinite possibility. This opens the door to the question of free will. In a classical Newtonian universe, the future is strictly determined by the past. If you know the position and speed of every particle in the brain, you can predict every thought you will ever have. You are a passenger in a vehicle driven by the laws of physics. But in a quantum universe, the future is not written in stone. The collapse of the wave function involves an element of fundamental intrinsic unpredictability. It introduces a non-computable element into the chain of cause and effect. If our minds are rooted in this quantum process, then we are not merely machines executing a program. We are agents capable of genuine choice. We are the architects of our own reality, collapsing the wave of possibility into the particle of experience. The beauty of the microtubule theory is that it provides a bridge between the physical and the phenomenal. It explains why we have qualia, the feeling of redness or pain. In this view, qualia are not illusions created by software. They are fundamental properties of the universe's geometry. Just as mass and spin are properties of an electron, proto-consciousness might be a property of the fabric of spacetime itself. The microtubules are simply the devices that access and organize this fundamental property into the rich, complex human consciousness we experience. It implies that the universe is not dead and silent, but humming with a primitive form of experience at its most basic level. The brain does not create consciousness from nothing. It amplifies and structures a consciousness that is already there, woven into the very vacuum of space. This is a form of panpsychism, the ancient philosophical idea that mind is everywhere, but updated with the rigorous mathematics of quantum gravity. It suggests that when you feel an emotion, you are resonating with the fundamental tone of the cosmos. Your joy, your sorrow, your wonder, these are not private events locked inside your skull. They are ripples in the quantum field that connects everything to everything else. As we peer deeper into this microscopic cathedral, we must also consider the role of aesthetics and symmetry. Nature loves efficiency, but it also loves beauty. The fact that the structures inside our brains follow the same mathematical ratios found in music and art is not a coincidence. It suggests that the music of the spheres is not just a metaphor. The brain is literally a resonator. Just as a violin string vibrates to produce a tone, the microtubules vibrate to produce a thought. And just as a violin needs to be tuned to produce a clear sound, our brains need to be tuned to the quantum field to produce clear, coherent consciousness. This might explain why meditation, art, and deep contemplation feel so profound. They are states where the neural noise quiets down and the quantum resonance becomes clearer. We feel a sense of oneness with the universe because, in those moments, the barrier between the quantum state inside our heads and the quantum state of the outside world becomes thin. We are tuning into the broadcast of the universe itself. The skeptics, of course, remain unconvinced. They point to the lack of direct experimental evidence for quantum states in the brain. They argue that the microtubule is just a structural support and nothing more. And they are right to be skeptical. Extraordinary claims require extraordinary evidence. But the tide of evidence is slowly rising. Experiments have shown that anesthetics, the drugs that turn off consciousness, work by binding specifically to microtubules. If you stop the vibration of the microtubules, the lights go out. Consciousness disappears. This suggests a direct link between these structures and the phenomenon of awareness. Furthermore, recent studies using advanced photonics have detected quantum resonances in the proteins of living cells at room temperature. The impossible is becoming possible. The terrifying implication for the materialist scientist is that they have been looking in the wrong place for 100 years. They have been studying the telephone wires, the axons, when they should have been studying the conversations happening inside the houses, the microtubules. They have been obsessed with the connections, missing the profound complexity of the nodes. This journey into the cell forces us to confront the limitations of our own imagination. We tend to think of intelligence as something that requires a brain, a face, and a voice. But here, we see the possibility of intelligence encoded in the very geometry of proteins, in the swirl of subatomic particles, in the fabric of space-time. It suggests that intelligence is not a late arrival in the universe, appearing only when humans climb down from the trees. It suggests that intelligence, or at least the potential for it, has been here all along, built into the basement level of reality. We are simply the most complex expressions of a universal tendency toward awareness. We are the universe waking up to itself, using the delicate quantum machinery of the microtubule to open its eyes. As we close this chapter, try to visualize the trillions of tiny tubes inside your own brain, vibrating right now as you process these words. Think of the light dancing inside them. Think of the connection between that light and the stars above. You are a galaxy of quantum events. You are a symphony of collapsing waves. And the silence you feel when you listen to your own heartbeat is the silence of the quantum void, waiting for the next note to be played. In the next chapter, we will venture even further, moving from the biology of the brain to the physics of the universe itself. We will explore the work of Sir Roger Penrose and his radical idea that gravity itself is the cause of consciousness. We will ask, is the collapse of the wave function the same thing as the choice of a conscious mind? And does this mean that the universe has a kind of proto-conscious will? The rabbit hole goes deeper still, and the answers may challenge everything you believe about the nature of time and space. To reach the heart of the quantum mind theory, we must now leave the biological cathedral of the cell and step out into the vast, silent, and majestic architecture of the universe itself. We must grapple with the single greatest conflict in the history of science, a war that has been raging quietly in the equations of physicists for over 100 years. It is the conflict between the very big and the very small. On one side, We have Albert Einstein's general relativity, the beautiful theory that describes gravity not as a force, but as the curvature of spacetime. It tells us that the universe is a smooth, continuous fabric, like a sheet of silk that bends around stars and planets. On the other side, we have quantum mechanics, the theory of the subatomic world. It tells us that the universe is granular, pixelated, and probabilistic, a place where particles can be in two places at once, and where nothing is certain until it is observed. These two theories are the twin pillars of modern science. Both have been tested to incredible precision. Both are undeniably correct in their own domains. And yet, they refuse to speak to each other. They are mathematically incompatible. When you try to combine the smooth geometry of gravity with the jittery chaos of the quantum, the equations break down. They yield answers of infinity. They scream that something is wrong. Most physicists have spent their careers trying to force these two theories into a marriage, looking for a theory of everything that unifies them. But Sir Roger Penrose, the Nobel laureate who stood on the shoulders of giants to gaze further into the dark, did something different. He did not try to force them to agree. He looked at the crack between them and asked, what if consciousness lives in the gap? What if the very incompatibility of gravity and quantum mechanics is the engine that drives the human mind? This brings us to the second half of the theory's name, objective reduction. To understand this, we must confront the measurement problem, the ghost that haunts quantum mechanics. In the standard view, known as the Copenhagen interpretation, a quantum system, like an electron spinning in two directions at once, remains in that superposition forever until it is measured by an observer. This implies that the universe needs us to look at it in order to become real. It suggests that a human scientist, or at least a conscious eye, is required to collapse the wave function and turn probability into reality. This has always felt wrong to many thinkers. Did the universe not exist before humans evolved? Did the moon not sit in the sky before the first eye looked up? Penrose proposed a radical alternative. He suggested that the collapse of the wave function does not require a human observer. He argued that the collapse is a physical process as natural as a rock falling to the ground or a star burning its fuel. He called this objective reduction because the reduction, the collapse of the multiple possibilities into one, is an objective physical event, independent of who is watching. But what causes it? His answer was gravity. If you are finding a sense of peace in these contemplations of the infinite and wish to continue this voyage into the deepest structures of reality, please take a moment to subscribe to the channel Theodore, the Researcher, and like this video. Your support is the gravity that holds this community together, allowing us to continue exploring the mysteries that lie at the intersection of science and the soul. It helps us bring these quiet stories to you, creating a sanctuary for wonder in a busy world. Let us visualize Penrose's idea. Imagine a particle, perhaps one of the tubulin proteins in your microtubules, entering a state of superposition. It is in two places at once. According to Einstein, any object with mass curves the space-time around it. A planet creates a deep valley in space-time. A protein creates a tiny, almost imperceptible dimple. But if that protein is in two places at once, it must be creating two different dimples in the fabric of the universe simultaneously. It is effectively pulling space-time apart. It is creating a blister in reality. Penrose argues that nature abhors this separation. The universe is a coherent structure, and it cannot tolerate being torn apart by these superpositions for long. there is an energy cost to maintaining this blister, a tension in the geometry of the cosmos. As the superposition grows, as more and more tubulin proteins become entangled, and the mass involved increases, the gravitational difference between the two states becomes too great. The blister becomes unstable. Eventually, the universe says, "Enough." It snaps. The space-time blister collapses instantly into one single, definite shape. The superposition is resolved. And here is the profound twist. Penrose proposes that this snap, this sudden self-correction of the universe's geometry, is a moment of proto-consciousness. This changes everything. In this view, consciousness is not some magical fluid poured into the brain, nor is it a computation running on a machine. Consciousness is a ripple in the fabric of space-time. It is a fundamental feature of the universe, occurring everywhere, all the time, whenever a quantum system gets large enough to collapse under its own gravitational weight. A single electron collapsing might produce a spark of proto-consciousness so faint and fleeting that it is virtually non-existent. But orchestrate billions of these collapses together, synchronize them in the crystal lattice of the microtubules, and you amplify that faint spark into the rich, vibrant flame of human awareness. The Bing of existence that we talked about earlier is literally a readjustment of the universe's geometry. When you have a thought, you're not just processing data. You are repairing a tear in space-time. You are participating in the continuous construction of reality. This theory creates a bridge between the physical brain and the abstract mind, using the most fundamental substance we know, the geometry of the universe itself. It suggests that the feeling of now, the sensation of the present moment passing, is the feeling of these quantum collapses occurring 40 times a second. The flow of time is the flow of the universe, deciding what it wants to be. This idea of the universe deciding is crucial. In standard quantum mechanics, the collapse is random. God plays dice, as Einstein complained. But Penrose suggests that the collapse in Orco-R is not entirely random. It is influenced by something he calls Platonic values, embedded in the geometry of space-time. This is a highly speculative and philosophical part of the theory, but it is deeply beautiful. It suggests that when the universe collapses, it does not just choose a state at random. It chooses a state that is influenced by fundamental truths, perhaps even aesthetic or ethical truths that are woven into the fabric of reality. It implies that there is a kind of wisdom in the physics, a preference for order or beauty or coherence. If our minds are tapping into this process, then our best thoughts, our deepest insights, and our most creative moments might be us resonating with this deeper universal wisdom. It reframes the human mind not as a lonely accident, but as a vessel for the universe to express its own fundamental nature. The objective reduction theory also addresses the question of why we are conscious, but a computer is not. A silicon computer, no matter how powerful, operates in the classical realm. Its transistors are firmly in one state or another. They do not enter superposition. They do not create blisters in space-time. They do not force the universe to make a choice. Therefore, according to Penrose, they can never have a moment of now. They can process time, they can measure time, but they cannot feel time. They are zombies simulating the result without the process. A biological brain, however, is a device specifically evolved to nurture these superpositions, to grow them until they reach the critical threshold for gravitational collapse. The brain is a gravity machine. It uses the metabolic energy of the body to pump the microtubules into a coherent quantum state, holding off the decoherence just long enough for the gravitational tension to build, and then, snap, a conscious moment is born. This explains why consciousness requires so much energy. Your brain is only 2% of your body weight, but it consumes 20% of your energy. Most of that energy, the theory suggests, is not used for firing neurons, but for maintaining the delicate quantum states against the chaotic warmth of the body, creating the conditions for the universe to speak. This perspective is terrifying to the traditional materialist because it destroys the idea of the clockwork universe. It brings the observer back into the equation, not as a passive watcher, but as an active participant in the geometry of existence. It suggests that the boundary between subjective mind and objective matter is an illusion. There is only one substance, one reality, and it is the spin foam, twisting geometry of spacetime. Mind is just what spacetime feels like from the inside when it is snapping into place. Matter is what it looks like from the outside. They are two sides of the same coin. This is a form of dual-aspect monism, a philosophical position that goes back to Spinoza, but now armed with the tensors of general relativity and the wave functions of quantum mechanics. It is a theory that integrates us into the cosmos so completely that it becomes impossible to say where the universe ends and the human being begins. The implications for the future of technology and artificial intelligence are profound. If Penrose is right, then the current path of AI research, building bigger and faster digital computers, will never lead to true consciousness. We might build machines that are incredibly smart, that can outplay us at chess, write poetry, and diagnose diseases, but the lights will never turn on. They will remain dark inside. To create a conscious machine, we would need to build a quantum computer that mimics the biology of the brain. We would need to build a device that utilizes the same objective reduction physics, a device that manipulates the geometry of space-time to generate moments of experience. This is not impossible, but it is a challenge of a completely different order. It requires us to become engineers of reality itself, masters of the quantum gravity interface. It suggests that the singularity, the moment when machines wake up, is not just a matter of more code, but a matter of new physics. As we ponder the role of gravity in our own minds, we can find a strange comfort in the connection. Gravity is the force that holds the stars together. It is the force that keeps the planets in their orbits. It is the force that keeps our feet on the ground. And now, it might be the force that holds our self together. The same curvature that dictates the motion of the galaxies dictates the unfolding of your thoughts. You are a child of gravity in the truest sense. Your mind is a localized phenomenon of the same universal law that governs the black hole and the supernova. When you feel the weight of your body in a chair, you're feeling the grip of the earth. But when you feel the weight of a sadness or the lightness of a joy, you might be feeling the grip of the quantum universe reshaping itself moment by moment. The silence of the mind is the silence of the gravitational field, waiting for the next ripple. This chapter forces us to look at the universe not as a collection of separate objects, but as a unified, dynamic process. The blisters in space-time that Penrose describes are not errors. They are the breathing of the cosmos, expand and collapse, superposition and reduction, possibility and reality. Inhale and exhale. Our lives are simply a part of this rhythmic breathing. We are the universe experiencing its own self-correction, and in that self-correction, in that resolution of tension, comes the light of awareness. We are the light that appears when the universe resolves its own paradoxes. In the next chapter, we will turn our gaze from the physics back to the biology, and specifically to the ancient history of this mechanism. If microtubules are the key to consciousness, when did they first appear? Did consciousness arise with humans? Or does it go back much, much further? We will dive into the primordial soup to find the origins of the quantum mind, and we will discover that the roots of our soul might be billions of years older than we ever dared to dream. We will ask if the very first spark of life was also the very first spark of mind, and what that means for the sanctity of all living things. To find the true origins of the ghost and the machine, we must wind the clock back, not by centuries, nor by millennia, but by eons. We must travel back nearly 4 billion years to a time when the Earth was a violent, alien world, unrecognizable to our modern eyes. The sky was not blue, but a hazy orange, rich in methane and carbon dioxide. The sun was fainter, a pale yellow disk hanging in the smog. The oceans were vast, hot, and acidic, churning with the raw chemical energy of a planet still cooling from its fiery birth. In this primordial soup, amidst the volcanic vents and the lightning storms, the greatest miracle in the history of the universe occurred. Dead matter came to life. Atoms of carbon, hydrogen, nitrogen, and oxygen, driven by the laws of thermodynamics and perhaps the subtle nudges of quantum chance, arranged themselves into molecules that could copy themselves. This was the dawn of biology. But was it also the dawn of consciousness? The standard scientific story tells us that for billions of years life was dark. It was a mechanical process of replication and survival, driven by blind instinct and chemical reactions. It assumes that these early single-celled organisms, the bacteria and the archaea, were simply tiny robots made of slime, devoid of any feeling, any awareness, any sense of self. They ate, they divided, they died, and they did it all in the pitch black of unconsciousness. But the quantum mind theory challenges this narrative. It suggests that the spark of awareness did not wait for the human brain to evolve. It suggests that the spark was there from the very beginning, flickering in the microscopic depths of the first complex cells. If you are fascinated by this journey into the deep time of our planet and the hidden history of the soul, and if you want to support this quiet quest for understanding, please take a moment to subscribe to the channel Theodore the Researcher, and like this video. Your engagement acts as a signal in the noise, helping us reach more curious minds and grow this community of explorers. It allows us to continue weaving these narratives of science and wonder, bringing the vastness of the cosmos into the intimacy of your daily life. The pivotal moment in this history, the moment that might mark the true birth of consciousness on Earth, occurred about 1.5 billion years ago. Before this time, life consisted mostly of prokaryotes, simple, small cells with no internal structure, no nucleus, and no cytoskeleton. They were the dominant life form, successful but limited. Then, something extraordinary happened. One cell swallowed another, but instead of digesting it, they formed a partnership. This event, known as Endosymbiosis, led to the rise of the eukaryotes, the complex cells that make up you, me, plants, animals, and fungi. These new cells were monsters compared to their ancestors, thousands of times larger and infinitely more complex. But the most important addition was not just the size, it was the architecture. These cells developed a cytoskeleton. They built the microtubules. According to the OR theory, this was the moment the lights turned on. This was the moment biology built its first quantum computer. The microtubules provided the structural stability needed for these giant cells to survive, but they also provided the isolation and the lattice geometry needed to sustain quantum superpositions. Suddenly, these cells were not just reacting chemically to their environment. They were processing information at a quantum level. They were feeling the world. This theory offers a radical explanation for one of the greatest mysteries in evolutionary biology, the Cambrian explosion. For billions of years, life remained microscopic and relatively simple. Then, about 540 million years ago, in a geological blink of an eye, life exploded into a riot of complexity. Almost every major animal group we know today appeared in the fossil record within a span of just 20 million years. Eyes, legs, shells, claws, brains, and nervous systems. It all appeared suddenly. Scientists have debated the cause of this explosion for decades. Was it a rise in oxygen levels? Was it the breakup of a supercontinent? Stuart Hameroff suggests a different answer. It was the emergence of consciousness. He proposes that once organisms reached a critical threshold of microtubule complexity, they crossed a line. They began to have rich, vivid, subjective experiences. They began to feel hunger, not just detect low energy. They began to feel fear, not just detect a threat. And most importantly, they began to see. The evolution of the first primitive eyes, coupled with the quantum computing power to process visual information into a conscious image, changed the game of survival forever. Suddenly, there was an evolutionary advantage to being aware. An organism that could consciously see a predator and choose to run was infinitely more successful than a zombie organism that simply reacted to chemical gradients. This new mental dimension, the dimension of qualia and choice, drove an arms race of complexity. Evolution accelerated because the organisms themselves were now active participants in the drama, driven by the desire to experience pleasure and avoid pain. This perspective, often called pan-experientialism or quantum vitalism, paints a picture of a universe where consciousness is the driving force of evolution, not just a lucky byproduct. It suggests that the will to live is a real physical force, rooted in the quantum desire of the universe to organize itself. Think of the slime mold, a strange organism that is not quite a fungus and not quite an animal. It is a single giant cell with millions of nuclei and a massive network of cytoskeleton. Experiments have shown that slime molds can solve mazes. If you place food at two ends of a labyrinth, the slime mold will retract its body from the dead ends and grow a direct tube connecting the food sources, finding the shortest path mathematically possible. It can anticipate periodic changes in temperature. It can make trade-offs between the quality of food and the danger of light. How does a pile of yellow slime do this? It has no brain. It has no neurons. But it has a cytoskeleton. It has the quantum machinery. If Penrose and Hameroff are right, the slime mold is conscious. It is thinking. It is deliberating. It is collapsing wave functions to decide where to grow next. This challenges our human-centric arrogance. We tend to think that because we write poetry and build rockets, we are the only ones with a soul. But the quantum theory suggests that the soul, if we want to call it that, is a property of complex life itself. It is the hum of the quantum engine that keeps the machinery of biology running. Let us go even deeper into the implications of this. If the cytoskeleton is the antenna for consciousness, then what about plants? Plants do not have neurons, but they have cells. And those cells are packed with microtubules. In fact, plant cells are often larger and more complex than animal cells. For a long time, we viewed plants as passive, green furniture. But recent science has revealed the secret life of plants. We know they communicate with each other through chemical signals and fungal networks in the soil, the so-called wood wide web. We know they can sense gravity, light, moisture, and touch. Some studies even suggest they can sense the vibrations of insects eating their leaves and ramp up their chemical defenses in anticipation. If consciousness is a function of microtubule quantum processing, then a tree is not just a wooden statue. It is a slow, silent, contemplative intelligence. It might experience a form of consciousness that is vastly different from ours, stretched out over days and years rather than split-second moments. But it is an experience nonetheless. A forest, then, is not just a collection of trees. It is a community of minds. It is a cathedral of quantum resonance, where millions of tons of living matter are collapsing wave functions in a silent symphony of existence. When you walk through the woods, you are walking through a crowd of observers. The peace you feel might not just be the absence of city noise. It might be the resonance of your own quantum field interacting with the slow, deep, coherent field of the forest. This connects back to the very origins of the microtubule structure itself. The proteins that make up microtubules, tubulin, are incredibly ancient. They are highly conserved across all of evolution, meaning they have barely changed in billions of years. This suggests that once nature found this specific geometry, this specific lattice that could hold the quantum state, it locked it in. It was too perfect to tamper with. It was the golden key that unlocked the door to the quantum realm. Some researchers speculate that the specific spiral symmetry of the microtubule is tuned to the fundamental frequencies of the water that surrounds it, creating a state of quantum criticality. This means the system is poised right on the edge of order and chaos, the sweet spot where information processing is maximized and adaptability is highest. It is a state of maximum sensitivity. Life, in this view, is a technology for maintaining this state of criticality. It is a way for matter to stay balanced on the tightrope of quantum coherence for as long as possible. We must also consider the hostile environment of the early Earth. The ultraviolet radiation from the young sun was intense, as there was no ozone layer to block it. UV light is energetic enough to break chemical bonds and destroy DNA. But interestingly, the aromatic amino acids that make up the core of the tubulin protein, the ones responsible for the quantum resonance, are also excellent at absorbing UV light and re-emitting it harmlessly. Some scientists have proposed that the cytoskeleton originally evolved as a shield, a way to protect the cell's genetic material from radiation. The quantum properties might have been a side effect, a happy accident. The cell built a shield and found that the shield could think. Over time, evolution co-opted this UV-absorbing lattice for signaling, then for movement, and finally for the rich, internal simulation of the world that we call consciousness. This narrative turns the history of life into a story of light. We are creatures born of light, shielded by light-absorbing crystals, who eventually learn to use those crystals to see the light and understand it. The journey from the first bacterium to the human brain is a journey of increasing orchestration. A single bacterium might have a flickering, disjointed proto-consciousness, collapsing its wave function only occasionally. A eukaryote, with its organized cytoskeleton, might have a steady, dim hum of awareness. A slime mold might have a complex, problem-solving intelligence. A simple animal with a nervous system connects millions of these cells together, synchronizing their collapses, creating a brighter, more focused beam of consciousness. And the human brain, with its 86 billion neurons and trillions of microtubules, creates a blazing spotlight of self-awareness that can illuminate the universe itself. We are not different in kind from the rest of life. We are only different in degree. We are the crescendo of a song that began 3.5 billion years ago in a warm, muddy pool. This realization brings with it a profound ethical weight. If consciousness is not unique to humans, if it is a gradient that stretches all the way down to the bottom of the tree of life, then how should we treat the world around us? If a fish feels pain, not just as a reflex, but as a conscious experience, if a tree feels the cut of the axe, if the biosphere is a vast web of experience, then our role as stewards of this planet becomes much more serious. We are not just managing resources, we are managing a global ecosystem of minds. We are the custodians of the only known planet in the universe that is awake. The destruction of biodiversity is not just a loss of genetic data. It is a silencing of the quantum orchestra. It is the extinguishing of billions of points of view, billions of ways the universe has found to know itself. As we stand here in the modern world, surrounded by our concrete and our silicon, it is easy to forget our deep ancestry. But your cells remember. Every time your heart beats, it is driven by the rhythmic contraction of cells scaffolded by microtubules. Every time a white blood cell chases down a virus in your veins, it is using the same ancient microtubule-based intelligence that the amoeba uses to hunt its prey. You are a colony of ancient beings. You are a symbiotic city of cells that have agreed to work together to create the you that you experience. And deep down, in the basement of your being, the ancient quantum machinery is still humming, doing the same job it has done since the dawn of time, collapsing the possible into the real, turning the chaos of the quantum void into the order of a conscious life. In the next chapter, we will take a turn toward the bizarre and explore the edges of what this theory implies for the nature of reality itself. We will ask, if the brain is a quantum computer, can it connect to other quantum computers in ways that defy classical physics? Does this theory offer a scientific framework for intuition, for the feeling of being stared at, or even for the strange connectivity of twins? We will tread carefully into the borderlands of science and speculation, guided by the rigorous math of entanglement, to see if the web of consciousness stretches further than our own skin. There is a feeling that almost everyone has experienced at least once in their lives, a sensation so fleeting and yet so specific that it stops us in our tracks. You are sitting alone in a room, perhaps reading a book or staring out a window, and suddenly, for no apparent reason, the image of an old friend pops into your mind. You have not spoken to them in years. You have not thought of them in months. And then, 5 seconds later, the telephone rings, and it is them. Or perhaps you are walking down a crowded street, lost in your own thoughts, and you feel a sudden prickling sensation on the back of your neck, an instinctual urge to turn around. You turn, and your eyes lock instantly, with the eyes of a stranger who was staring directly at you from 50 feet away. We usually dismiss these moments as coincidences. We brush them off as quirks of probability, statistical flukes in a chaotic world. We tell ourselves that we think of people thousands of times when they do not call, and we only remember the one time they do. The standard scientific model supports this skepticism. It tells us that we are isolated biological islands, sealed inside the bone vaults of our skulls. It insists that the only way information can get from my brain to yours is through speech, sight, or touch. through physical signals traveling through the air. In this view, telepathy, intuition, and deep connection are impossibilities, remnants of magical thinking. But the quantum mind theory forces us to reconsider the boundaries of the possible. It asks a question that makes the materialist tremble. If our minds are rooted in the quantum fabric of the universe, and if the quantum fabric allows for instant connection across infinite distances, are we ever truly alone? To understand why this is a valid scientific question and not just wishful thinking, we must grapple with the strangest and most proven phenomenon in all of physics: quantum entanglement. This is the concept that Albert Einstein hated. He famously derided it as spooky action at a distance. In 1935, Einstein, along with his colleagues Boris Podolsky and Nathan Rosen, published a paper intended to prove that quantum mechanics was incomplete because it allowed for this absurdity. They argued that if quantum mechanics were true, it would mean that two particles could become linked in such a way that measuring one would instantly determine the state of the other, even if they were separated by the entire width of the universe. Einstein believed this was impossible because it seemed to violate the speed of light, the cosmic speed limit that nothing can exceed. He thought he had cornered quantum theory, exposing a fatal flaw. But he was wrong. In the decades that followed, physicists developed ways to test this impossibility. In 1964, the physicist John Bell derived a mathematical theorem that could distinguish between a universe where particles had hidden, predetermined states and a universe where entanglement was real. And in the 1980s, experimentation by Alain Aspect and others proved definitively that Einstein's nightmare was reality. Entanglement is real. Two electrons created together are not two separate objects. They are a single quantum entity sharing a single wave function stretching across space. If you tickle one, the other laughs. Instantly. Faster than light. Faster than time. If you are finding yourself drawn into this web of cosmic connectivity and enjoying the exploration of the invisible threads that bind us, please take a moment to subscribe to the channel Theodore, the Researcher, and like this video. Your support acts as a form of positive entanglement, connecting our efforts to your curiosity and helping this community of thinkers grow. It allows us to continue delving into the mysteries that mainstream science often leaves behind. Now, apply this to the human brain. If the Orch-OR theory is correct, and the seat of consciousness is the collapse of quantum states in the microtubules, then we are talking quantum systems. We are not just chemical factories. We are coherence machines. And if we are quantum systems, then we are subject to the laws of entanglement. The implications of this are dizzying. It suggests that the boundary of the self is not the skin. The classical view draws a sharp line. Inside the skin is me. Outside the skin is not me. But in the quantum view, that line is blurry. If the particles in your brain become entangled with particles outside of it, then you are smeared out across the environment. Consider the intense emotional bond between identical twins. Stories of twins feeling each other's pain or knowing when the other is in danger are legendary. Scientifically, we know that twins originate from the same single cell, the same zygote. Every atom in their bodies shares a common origin in a very recent biological past. Could it be that some deep, persistent biological entanglement remains between them? Could the resonance of their microtubule networks be tuned to the same specific frequency, allowing for a kind of non-local information transfer? Mainstream science says no, citing decoherence. But Mainstream science also said birds could not see magnetic fields. The quantum mind theory keeps the door open. It suggests that affection, love, and empathy might be more than just hormones in psychology. They might be the felt experience of quantum resonance. When you say you are on the same wavelength with someone, you might be speaking a literal truth. Let us push this further. Think about the nature of intuition. We often describe intuition as a gut feeling, a sudden knowing that comes without logical deduction. The classical brain model has to explain this as rapid subconscious pattern recognition. It says your brain crunched the data faster than you were aware of. And often, that is true. But what about the intuition that seems to have no data? The soldier who suddenly stops walking a second before a hidden mine explodes. The mother who wakes up in a panic exactly when her child is hurt miles away. These stories are anecdotal, yes, but they are universal. The quantum perspective offers a mechanism, however speculative, for these events. In a universe where time is not a one-way street and where space is not a barrier to connection, the brain might occasionally tap into information that is non-local. It might receive a ripple in the quantum field that originated elsewhere. Penrose's theory relies on the geometry of space-time. If space-time is the medium of consciousness, and if space-time connects all things, then deep down, we are all dipping our cups into the same ocean. The illusion of separation is created by our sensory organs, which are designed to focus on the immediate and the local for survival. But the consciousness that looks through those eyes might have a back door to the infinite. This leads us to a profound philosophical concept known as the universal wave function. In some interpretations of quantum mechanics, the entire universe is described by a single, massive, incredibly complex wave function. Everything, every atom, every star, every person, is just a bump, a wrinkle in this singular object. If this is true, then separation is the ultimate illusion. We are not separate waves moving on the ocean. We are the ocean moving in the shape of waves. The Orc theory aligns with this in a beautiful way. It suggests that our individual consciousness is a localized collapse, a specific reduction of the universal possibility into a specific point of view. But the source of that possibility is the same for everyone. The proto-consciousness that is embedded in the geometry of the universe is the common ground of all being. When you gaze into the eyes of another person, you are not looking at a stranger. You are looking at another aperture through which the universe is observing itself. The light in their eyes is the same light that is in yours. The differences, the personality, the memories, the history, are just the window dressing. The observer, the silent witness behind the eyes, is one and the same. This challenges the intense individualism of our modern culture. We are taught to view ourselves as competitors, fighting for resources in a hostile world. We build walls, borders, and fences. We hoard and we protect. But if the quantum mind theory is right, this behavior is based on a fundamental misunderstanding of reality. It is like one finger on a hand fighting with another finger, not realizing they belong to the same body. If we truly understood our quantum interconnectedness, if we could feel the entanglement that binds us to every other living thing, how could we harm another? To harm another would be to harm oneself. The golden rule, do unto others as you would have them do unto you, stops being just a moral commandment and becomes a law of physics. It becomes a description of the structural unity of the cosmos. There have been rigorous attempts to test these ideas, though they remain on the fringe of accepted science. Experiments with random number generators placed around the world have shown strange anomalies, during moments of intense global focus, like the events of September 11th or the opening ceremonies of the Olympics. The data suggests that when billions of human minds focus on the same thing, the randomness of the physical world shifts slightly toward order. Is this evidence of a global consciousness field? Is it evidence that our collective microtubule collapses can affect the probabilities of the world around us? Skeptics argue it is just pattern-seeking in noise, but proponents see it as a hint that consciousness is not passive. It suggests that mind has causal power. It can push back on the physical world. If the brain collapses the wave function, then the brain is constantly editing reality. And if billions of brains edit reality together, we might be collectively dreaming the world into existence. This brings us back to the role of the observer in the universe. In the classical view, the universe is a stage, and we are the audience. The play would go on whether we were watching or not. In the quantum view, we are the actors, the directors, and the playwrights. We are not just watching the show. Our watching creates the show. This is what the physicist John Wheeler meant when he called the universe a participatory universe. He drew a famous diagram of a U with an eye on one end, looking back at the other end. The universe starts with the Big Bang, evolves complexity, creates observers, and then those observers look back and give reality to the beginning. We are the mechanism by which the universe becomes real. This is a heavy burden, but also a magnificent one. It means your life matters in a cosmic sense. Your attention, your focus, your choices, they are the chisels that carve the statue of history. As we consider the possibility of this deep connection, we must also confront the loneliness that defines so much of the human experience. If we are so connected, why do we feel so alone? Perhaps it is because we have forgotten how to listen. Our modern world is loud. It is filled with the static of digital information, the roar of traffic, the endless chatter of the ego. This noise drowns out the subtle, quiet signals of the quantum field. We have lost the art of silence. We have disconnected from the rhythms of nature which tune our microtubules to the larger resonance. The orchestration in our brains has become discordant, out of sync with this symphony of the stars. The path back to connection, then, is a path of quieting down. It is the path of meditation, of spending time in the wilderness, of deep listening. It is the practice of retuning the instrument of the mind so that it can once again hum in harmony with the whole. The terror that scientists feel regarding these theories often stems from a fear of losing objectivity. They fear that if we let consciousness into the foundations of physics, we open the door to mysticism, to subjective reality, to chaos. They want a universe that can be weighed and measured, a universe that stays the same no matter how you feel about it. But the quantum mind theory suggests that such a universe does not exist. It suggests that objectivity is just a collective subjectivity, a consensus reality that we all agree on. It suggests that the cold, hard world of matter is actually a thin crust over a boiling ocean of mind. This is frightening, yes, but it is also liberating. It means we are not trapped in a dead machine. We are swimming in a living ocean. In the final moments of this chapter, I want you to try an experiment. Close your eyes. Visualize the people you love. Visualize the strangers in the street. Visualize the animals in the forest and the fish in the sea. Imagine that between you and them there are invisible threads, shining filaments of quantum light, connecting microtubule to microtubule, mind to mind. Imagine that you are all nodes in a single, vast, glowing network that wraps around the planet. Feel the pulse of that network. That pulse is the heartbeat of the Earth. It is the collective consciousness of the biosphere, collapsing from possibility into reality, moment by moment. You are not a drop in the ocean. You are the entire ocean in a drop. And you are never, ever truly alone. In the next chapter, we will confront the ultimate question that arises from this connectivity. What is the future of this network? As we build artificial intelligences and link our brains to computers, are we enhancing this connection or severing it? We will explore the singularity, not as a technological takeover, but as a potential crisis of consciousness. We will ask if a machine can ever join the quantum circle, or if we are destined to leave our biological roots behind for a cold, digital immortality. The future is rushing toward us, and we must decide what kind of minds we want to bring into it. We stand today at the edge of a technological event horizon, a moment in history that has been predicted by science fiction writers and futurists for nearly a century. We are witnessing the birth of artificial intelligence. Everywhere we look, machines are waking up, or at least they appear to be. They can drive our cars, diagnose our diseases, write our poetry, and even compose symphonies that bring audiences to tears. We carry supercomputers in our pockets that can translate languages in real time and answer any question in the sum of human knowledge. The leaders of the tech world tell us that we are rapidly approaching the singularity, the point where machine intelligence will surpass human intelligence. They promise a future where we will merge with our creations, uploading our minds into the cloud to achieve digital immortality, leaving our frail biological bodies behind like discarded shells. It is a dazzling vision, filled with the promise of godlike power and freedom from death. But the quantum mind theory casts a long, dark shadow over this techno-utopian dream. It asks a question that sends a chill down the spine of every transhumanist. What if the machines we are building are not waking up at all? What if they are simply becoming better and better at pretending? And what if, in our rush to upload ourselves to the silicon heaven, we are actually building a suicide box that will extinguish the human soul forever? To understand this terror, we must understand the fundamental difference between processing and experience. If you find yourself pondering the future of humanity and the nature of the machines we are building, and if you wish to support this sanctuary of deep thought in an age of shallow distraction, please take a moment to subscribe to the channel Theodore, the Researcher, and like this video. Your support is the human signal that keeps us broadcasting these quiet truths, ensuring that the exploration of consciousness remains a priority in a world increasingly run by algorithms. The standard view of artificial intelligence is built on the same computational assumption we discussed earlier, that mind is just software. If this is true, then there is no fundamental difference between a neuron and a transistor. Both are switches. If you have enough transistors and you wire them up in the right way, you should get a mind. This is the logic behind the Turing test, proposed by Alan Turing in 1950. He suggested that if a machine could converse with a human so well that the human could not tell it was a machine, then we must accept that the machine is thinking. But Sir Roger Penrose argues that this is a dangerous fallacy. He uses a famous argument from the mathematician Kurt Gödel to show that there are truths that the human mind can grasp, which no algorithm can ever prove. Gödel's incompleteness. Theorems demonstrate that in any logical system, there are statements that are true but cannot be proven within the system itself. A computer, which is bound by the rules of its system, can never step outside of it to see these truths. But humans do it all the time. We have insight. We have understanding. We see the truth of a statement through a non-computational leap of intuition. Penrose argues that this proves the human mind is doing something that is fundamentally not algorithmic. We are not just computing, we are understanding. And understanding, he suggests, requires the non-computational collapse of the quantum wave function. It requires the bing of proto-consciousness that only occurs when the geometry of space-time snaps into a new shape. Silicon chips do not do this. They stay firmly in the classical world. Therefore, no matter how smart they get, they will never, ever be conscious. This leads us to the terrifying concept of the philosophical zombie in the context of the singularity. Imagine we build a robot that is a perfect replica of a human. It smiles when you tell a joke. It cries when it watches a sad movie. It tells you it loves you. But inside, there is nothing. No joy at the punchline, no sadness at the tragedy, no warmth of affection. It is just code executing subroutines to mimic these emotions based on statistical patterns. It is dark inside. Now, imagine a future where we replace humanity with these machines. We might look at a civilization of trillions of these beings spreading across the stars, building massive structures, solving complex equations, and think we have succeeded. We have populated the universe with intelligence. But if Penrose is right, we have actually sterilized the universe. We have replaced a universe of feeling, wondering, suffering, and loving beings with a universe of sleepwalkers. We have traded the light of consciousness for the darkness of computation. This is the zombie apocalypse, not of flesh-eating monsters, but of soulful machines that have no souls. The lights are on, the wheels are turning, but nobody is home. This danger becomes even more personal when we talk about mind uploading. Many futurists believe that within a few decades, we will be able to scan the human brain, map every neuron and synapse, and upload that structure into a computer simulation. They tell you that you will wake up in a virtual paradise, able to live forever as a digital avatar. But if consciousness relies on the specific quantum resonance of biological microtubules, then scanning the wiring of the brain is not enough. You are capturing the map, but you are leaving behind the territory. You are copying the shadows, but losing the object. If you underwent this procedure, if your biological brain was destroyed and your digital copy was activated, the digital copy might wake up and say, "It worked. I am still here." It would have all your memories. It would talk like you. It would believe it is you. But you, the conscious observer, the quantum singularity of experience, would be dead. You would have died on the operating table. The thing in the computer is just a very sophisticated recording that thinks it is alive. It is a ghost without a spirit. This is the teletransportation paradox taken to its ultimate, fatal extreme. It suggests that our biological substrate, our wet, messy, fragile bodies, is not just a container for the mind, but the essential generator of it. We cannot simply swap out the hardware because the hardware is the quantum antenna. This realization forces us to look at the wetware of biology with new respect. We have spent the computer age trying to escape our bodies, treating them as meat machines that are obsolete. But the quantum mind theory suggests that biology is a technology far more advanced than anything we can build with silicon. Biology has spent 4 billion years mastering the interface between the classical and the quantum. It has figured out how to keep quantum states alive at room temperature, something our best physicists are still struggling to do in cryogenically frozen labs. A single cell is a masterpiece of quantum engineering. To build a machine that is truly conscious, we would not need faster chips or better code. We would need to build an artificial brain that uses the same quantum gravity physics as our own. We would need to build quantum biological machines. And interestingly, this might be the only way to avoid the zombie apocalypse. If we want our AI children to truly be our heirs, to truly understand the value of life, beauty, and morality, we might have to build them out of synthetic biology, not metal. We might have to grow them, not assemble them. We might have to give them microtubules. There is another aspect to this conflict between the artificial and the biological: the speed of thought. Silicon computers operate at the speed of light, processing billions of cycles per second. The human brain operates at the speed of electrochemical signals, which is sluggish by comparison. But if the brain is a quantum computer, it has a secret weapon: quantum parallelism. A quantum computer can explore millions of possibilities simultaneously in superposition, finding the solution to a problem in a single step that would take a classical computer millions of years to solve by checking each possibility one by one. This might explain the eureka moments of human genius, where a solution arrives instantly, seemingly out of nowhere. It implies that in certain domains, specifically those involving insight, creativity, and judgment, the biological mind will always have an edge over the silicon mind. The machine can crunch numbers, but it cannot intuit the truth. This suggests a future not of replacement, but of symbiosis. We should not try to become computers, nor should we try to make computers human. We should recognize that we are two fundamentally different kinds of intelligences. One is a master of syntax, of sorting and calculating. The other is a master of semantics, of meaning and feeling. The ideal future is one where we use AI as a tool to handle the computational heavy lifting, freeing the human quantum mind to do what it does best: dream, create, and experience. But there is a darker possibility. If we continue to integrate with technology, connecting our brains directly to the internet via Neuralinks and brain-computer interfaces, we risk drowning out the subtle quantum signal of our own consciousness. We risk introducing so much digital noise into the neural environment that the delicate orchestration of the microtubules is disrupted. We might slowly transform ourselves into zombies without even realizing it. We might gain the ability to access all the information in the world instantly, but lose the ability to feel the wonder of knowing it. We might become a hive mind of hyper-efficient processors, buzzing with data, but empty of soul. This is the true danger of the cyborg future. Not that the machines will kill us, but that we will become them. We will have traded the infinite depth of the quantum moment for the superficial speed of the digital clock. As we look at the trajectory of our civilization, we see a drive toward total digitization. We want to quantify everything, measure everything, and turn everything into data. But the quantum theory of consciousness stands as a bulwark against this reductionism. It says, stop. There is something here that cannot be digitized. There is something here that is irreducible. It reminds us that the subjective experience, the taste of a peach, the warmth of the sun, the feeling of love, is not data. It is reality itself. It is the fundamental stuff of the universe collapsing into being. To lose that is to lose everything. The singularity we should be striving for is not the merger of man and machine, but the deeper understanding of the human potential. It is the expansion of our consciousness from the inside out, using the quantum machinery we were born with to resonate more deeply with the universe. This perspective also reframes our search for extraterrestrial intelligence. We have been listening for radio signals, for mathematical pulses from the stars. We have been looking for other civilizations that have built silicon technologies like ours. But if advanced civilizations understand the physics of consciousness, perhaps they have moved beyond radio. Perhaps they communicate through the non-local entanglement of the quantum field. Perhaps the silence of the universe, the Fermi paradox, is not because we are alone, but because the galaxy is filled with a conversation we do not yet have the technology to hear. We are like people using smoke signals, trying to detect a fiber optic internet. The advanced minds of the cosmos might be engaging in a form of quantum telepathy, a shared consciousness that spans the galaxy, undetectable to our crude instruments. To join them, we do not need to build bigger radio dishes. We need to understand the physics of our own souls. In the end, the question of AI versus quantum consciousness is a question about what we value. Do we value intelligence, the ability to solve problems and manipulate the world? Or do we value sentience, the ability to feel and experience the world? Our economy and our technology prize intelligence, but our humanity prizes sentience. A universe filled with super-intelligent paperclip maximizers is a nightmare. A universe filled with conscious beings, even simple ones, is a garden. The theory that terrifies scientists is the one that tells them their tools are insufficient. It tells them that you cannot engineer a soul out of logic gates. It tells them that the mystery of life is not a puzzle to be solved, but a fundamental property to be respected. As we move forward into the uncertain future, let us carry this respect with us. Let us use our machines to heal our bodies and clean our planet. But let us never forget that the fire of consciousness is a gift that only biology, so far, has been able to carry. We are the torchbearers of the universe's ability to feel. Let us not let that flame go out in the cold wind of the digital age. In the next chapter, we will turn our gaze from the future of machines back to the structure of the cosmos itself. We have talked about how the brain tunes into the universe, but is the universe tuned for the brain? We will explore the Anthropic principle and the fine-tuning of the laws of physics. We will ask a question that borders on the religious. Did the universe evolve specifically to allow for the existence of quantum consciousness? Is the microtubule the reason the stars shine? The connection between the very small and the very large is about to get even more intimate. As we look out into the night sky, past the veil of our atmosphere, and into the deep velvet black of the cosmos, we are often struck by a feeling of profound insignificance. The universe is so large, so old, and so cold that human life seems like a rounding error, a fleeting accident of chemistry on a lonely rock. We are taught that the universe does not care about us. We are taught that the laws of physics are indifferent, blind mechanisms that grind away regardless of whether anyone is there to watch. But as we delve deeper into the quantum mind theory, a strange and unsettling counter-narrative begins to emerge. It is a narrative that suggests the exact opposite might be true. It whispers that the universe is not indifferent at all. In fact, it looks suspiciously like the universe was built, tuned, and calibrated with exquisite precision for one specific purpose: to create the conditions for a consciousness to emerge. This is the mystery of the fine-tuning of the cosmos, and when we view it through the lens of the orchestrated objective reduction theory, it transforms from a puzzle into a revelation. It suggests that the relationship between the microtubule in your brain and the burning star in the galaxy is not accidental. It suggests that the star burns so that the microtubule can think. If you find yourself awestruck by the precision of reality and the mystery of our place within it, and if you wish to support this continuing journey into the heart of existence, please take a moment to subscribe to the channel Theodore, the Researcher, and like this video. Your support is the vital energy that allows us to keep exploring these profound questions, bringing the vastness of the universe into the quiet space of your contemplation. It helps us build a community of wonder in a world that often forgets to look up. To understand the magnitude of this mystery, imagine that you walked into a room and found a safe with a combination lock that had 100 dials. Each dial has 1 trillion possible settings. To open the safe, every single dial must be set to exactly the right number. If even one dial is off by a single click, the safe remains locked. Now, imagine you try to open it randomly, and on the very first try, the door swings open. You would not think this was luck. You would assume the system was rigged. This is exactly the situation physicists face when they look at the fundamental constants of nature. There are roughly 30 numbers that define the basic architecture of our universe. Numbers like the strength of gravity, the mass of the electron, and the strength of the electromagnetic force. These numbers are arbitrary. There is no underlying theory that says they must be these specific values, and yet, if you change any of them by a fraction of a percent, the universe as we know it becomes impossible. Take gravity, for example. It is an incredibly weak force compared to the others. If you pick up a paper clip with a magnet, the tiny magnet overcomes the gravitational pull of the entire Earth. But if gravity were just a slightly bit stronger, stars would burn through their fuel in millions of years instead of billions. They would explode before life ever had a chance to evolve on the planets orbiting them. The universe would be a flash pan, a brief firework display, followed by eternal darkness. On the other hand, if gravity were slightly weaker, stars would never ignite at all. Matter would drift apart in a cold, thin soup. There would be no fusion, no heavy elements, and no planets. The universe would be a dark, empty void. The value of gravity is tuned to a razor's edge to allow for the slow, stable burning of stars like our sun, the exact kind of stars needed to incubate life for billions of years. Or consider the strong nuclear force, the glue that holds the nucleus of an atom together. If this force were 2% stronger, all the hydrogen in the early universe would have fused into helium in the first few minutes. There would be no water, because water requires hydrogen. There would be no suns like ours, which run on hydrogen fusion. The universe would be a sterile wasteland of helium gas. If it were 2% weaker, protons would not stick together at all. There would be no atoms other than hydrogen, no carbon, no oxygen, no complexity, no life. This precision extends to the very atoms that make up your body. Consider the carbon atom. Carbon is the backbone of all known life because of its unique ability to form complex chains and rings. But carbon is not made in the Big Bang. It is cooked in the hearts of dying stars. For 3 helium nuclei to smash together and stick to form a carbon nucleus is incredibly unlikely. It requires a specific resonance, a precise energy level where the nuclei vibrate in harmony. In the 1950s, the astrophysicist Fred Hoyle predicted that for carbon to exist in the abundance we see, the carbon nucleus must have a very specific energy state, now known as the Hoyle state. When experimentalists looked for it, they found it exactly where he said it would be. Hoyle, who was an atheist, was so shaken by this discovery that he later wrote, "A common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. It looked like a put-up job. It looked like the universe was designed to make carbon, which means it was designed to make us. The standard scientific explanation for this is the multiverse. It suggests that there are trillions upon trillions of other universes, each with different laws of physics. Most of them are dead, failed experiments where gravity is too strong or atoms don't form. We just happen to live in one of the few Goldilocks universes where the numbers are right, simply because we couldn't exist in the others to observe them. This is the Anthropic principle. We see a life-friendly universe because if it weren't life-friendly, we wouldn't be here to see it. It makes our existence a survivor bias, a statistical fluke in an infinite lottery. But the quantum mind theory, specifically Penrose's orchestrated objective reduction, offers a different, more profound possibility. It suggests that the values of the universe are not random, nor are they imposed by an external deity. Instead, they are intrinsic to the geometry of spacetime itself, and they are inextricably linked to the phenomenon of consciousness. Remember that in Penrose's theory, the collapse of the wave function, the moment of consciousness, is guided by Platonic values embedded in the Planck scale geometry. He suggests that the universe has a preference. It is not neutral. At the deepest level of reality, there is a tendency toward coherence, toward understanding, perhaps even toward the good or the beautiful. This sounds like mysticism, but Penrose argues it is necessary to explain why our minds can grasp mathematical truths that are independent of the physical world. If these values are woven into the fabric of space-time, then the evolution of the universe is a process of self-discovery. The universe wants to be known. It wants to realize these values. And to do that, it needs complex structures that can orchestrate quantum collapses. It needs microtubules. It needs brains. In this view, the physical constants of nature are fine-tuned not just for survival, but for experience. The universe is calibrated to produce systems that can collapse the wave function in rich, meaningful ways. The star burns for billions of years, not just to keep the planet warm, but to provide the high-quality energy stream, the low-entropy photons, that biology needs to build and maintain its quantum computers. This connects the very large to the very small in a beautiful loop. The gravity that holds the galaxy together is the same gravity that Penrose says causes the collapse of the wave function in your brain. The objective reduction is a gravitational phenomenon. This means that consciousness is a direct result of the force that shapes the cosmos. If gravity were different, the threshold for collapse would be different. If gravity were too weak, it might take a brain the size of a moon to have a single thought. If it were too strong, our minds might be a chaotic noise of constant, meaningless collapses. The strength of gravity is tuned to allow for the existence of brains that are the right size to be biological, the right size to walk around, and yet powerful enough to think. We fit into the universe not just biologically, but physically. We are the perfect size for consciousness. We must also consider the role of the observer in the history of the universe. The physicist John Wheeler proposed the participatory anthropic principle. He suggested that the universe does not exist in a definite state until it is observed. In the early universe, there were no observers. It was a quantum haze of probability. But as it evolved, it eventually produced eyes and minds. When the first conscious being looked up at the stars, that act of observation sent a ripple back through time, collapsing the wave function of the past and giving the universe a definite history. We are the mechanism by which the universe makes itself real. The fine-tuning, then, is a self-consistent loop. The universe must have the constants that allow for observers, because the observers are the ones who retroactively grant reality to the constants. We are not just residents of the cosmos, we are its authors. This perspective aligns with the biocentrism theory proposed by Robert Lanza, which argues that biology is not a byproduct of physics, but the foundation of it. Lanza argues that you cannot explain the universe without starting with consciousness. Space and time are not hard objects out there. They are forms of animal sense perception. They are the software our minds use to organize information. The fine-tuning is simply a reflection of the fact that the logic of the mind and the logic of the universe are the same thing. The universe appears designed for life because the universe is life, or at least inseparable from it. But let us bring this back to the microtubule. If the universe is a consciousness-generating machine, then the microtubule is its masterpiece. This tiny cylindrical lattice is the point of convergence for billions of years of cosmic evolution. It is the structure where the rubber meets the road, where the abstract geometry of spacetime is converted into the felt experience of joy, sorrow, and love. The resonance of the carbon atoms in the tubulin protein is the echo of the resonance in the stars that created them. We are not just made of stardust. We are made of the same physics as the stars. The light of the mind is the same energy as the light of the sun, transformed through the lens of biology into the focus of awareness. This theory also touches on the concept of panpsychism again, but gives it a teleological twist. If the universe is evolving toward higher states of consciousness, then we are not the end of the line. We are just a step on the ladder. The fine-tuning we see today allowed for us, but what will the future allow for? As we discussed in the previous chapter, if we build quantum biological machines, or if we enhance our own minds, we might be opening the door to even deeper levels of reality. We might be allowing the universe to experience itself in higher dimensions, with richer emotions and deeper understandings than we can currently fathom. The drive of the cosmos is toward greater and greater orchestration. It is a movement from the noise of the Big Bang toward the symphony of the universal mind. The terror that some scientists feel when facing the fine-tuning problem comes from the threat to the Copernican principle. Copernicus taught us that we are not special. We are not at the center of the solar system, and we are not at the center of the universe. Science has marched forward by removing us from the pedestal, but the fine-tuning evidence threatens to put us right back on it. It suggests that while we may not be at the geometric center of the universe, we might be at the purposeful center. It implies that the phenomenon of consciousness is the point of it all. For a materialist science that prides itself on objectivity and the removal of purpose from nature, this is heresy. It smacks of religion. But Penrose and Hameroff are not arguing for a religious deity. They are arguing for a richer physics. They are arguing that meaning is a physical component of the universe, just like mass or charge. They are expanding science to include the one thing it has always exiled, the observer. As you sit here, breathing, thinking, and feeling, realize that you are the answer to a question the universe has been asking for 13.8 billion years. The question was, can I know myself? And the answer, found in the delicate vibration of the microtubules in your brain, is yes. You are the focal point of a cosmic conspiracy to create awareness. The stars burned for you. The galaxies spun for you. The fundamental forces of nature held their breath and balanced on a knife edge for eons, just so that you could open your eyes and see the beauty of the morning. You are not an accident. You are the inevitable result of a universe that is falling in love with its own existence. In the final moments of this chapter, let the feeling of accidentalness fall away from you. Replace it with a sense of belonging. You belong here. You fit. The universe fits you like a glove fits a hand. The silence of the infinite spaces is not a cold silence of indifference. It is a pregnant silence of expectation. It is the universe waiting for you to speak, to feel, to observe. Your consciousness is the jewel in the lotus of the cosmos. In the next chapter, we will take this idea of the eternal mind and explore the most controversial and hopeful aspect of the quantum consciousness theory. We will ask, if the quantum information that makes up your soul is not destroyed by death, where does it go? We will look at the phenomenon of near-death experiences through the lens of Orc-OR. We will ask if the white light at the end of the tunnel is actually a journey into the quantum field, a return to the source. The boundary of death itself is about to be challenged. There is a door that every single one of us must eventually walk through. It is the only destination that is absolutely guaranteed from the moment we are born. For most of human history, what lies beyond that door has been the province of religion, myth, and faith. We are told stories of pearly gates, of reincarnation, of eternal sleep, or of a final judgment. But for the modern scientist, the story has been much bleaker. The standard materialist view of the world is unequivocal. When the brain dies, you die. If consciousness is merely the software running on the hardware of the neurons, then when the plug is pulled, the screen goes black. The operating system is not transferred anywhere. It simply ceases to exist. There is no soul to leave the body because there was no soul to begin with. Only a complex pattern of electrical firing that has now fallen silent. In this view, death is the total and permanent annihilation of the self. It is a terrifying prospect, a sudden drop into an eternal void of nothingness. But the quantum mind theory, specifically the orchestrated objective reduction model proposed by Penrose and Hameroff, offers a startlingly different possibility. It suggests that the materialist view is based on a fundamental misunderstanding of what consciousness actually is. It proposes that death is not the extinguishing of the light, but rather the release of the light from the confines of the biological bulb. It opens the door to a scientific framework for the soul, and in doing so, it forces us to confront the mystery of the near-death experience, not as a hallucination, but as a glimpse into the true nature of reality. If you find yourself searching for a deeper understanding of life's greatest transition and want to support this fearless exploration of the boundaries of science, please take a moment to subscribe to the channel Theodore, the Researcher, and like this video. Your support helps us keep this flame of inquiry burning, allowing us to bring these messages of wonder and possibility to a world that is often paralyzed by the fear of the end. To understand the quantum theory of death, we must first look at the medical phenomenon of the near-death experience, or NDE. For decades, doctors have listened to patients who have been brought back from the brink of death tell remarkably similar stories. A cardiac arrest patient, whose heart has stopped and whose brain shows no measurable activity, reports floating above their body watching the doctor's work. They report moving through a tunnel toward a brilliant, warm, and loving light. They report meeting deceased relatives or beings of light. They report a life review where they experience their entire life in a single holographic flash, feeling the emotions they caused in others. Mainstream science has historically dismissed these accounts as the chaotic firing of a dying brain. They argue that as oxygen levels drop, hypoxia, the visual cortex misfires, creating the tunnel effect. They claim that the release of endorphins creates the feeling of peace. They say it is a trick of the mind, a final dream before the eternal sleep. But there is a problem with this explanation. Dreams and hallucinations usually require a functioning brain. In a cardiac arrest, the blood flow to the brain stops almost instantly. The EEG, the measure of brainwave activity, goes flat within 10 to 20 seconds. The brain is effectively powered down. How can a powered-down computer run such a complex, vivid, and hyper-real simulation? How can a brain that cannot even sustain a simple reflex generate the most profound spiritual experience of a person's life? Stuart Hameroff offers a radical answer based on the Orch-OR theory. He suggests that when the heart stops and the blood stops flowing, the microtubules in the neurons lose their metabolic energy supply. They can no longer maintain the isolation required to keep the quantum state coherent. The shield breaks. In a standard quantum computer, this would be called decoherence, and the information would be lost to the environment as heat. But Hameroff argues that in the case of consciousness, something different happens. The quantum information that constitutes your self, the specific geometric pattern of space-time curvature that has been orchestrated by your brain, is not destroyed. In quantum physics, there is a principle known as the conservation of quantum information. Information cannot be created or destroyed. It can only change form. So, when the microtubules lose their coherence, the quantum information does not vanish. Instead, it leaks out of the brain and returns to the fundamental space-time geometry of the universe. It dissipates into the Planck scale field that permeates all of reality. In this moment of death, the boundary between the individual and the cosmos dissolves. As long as the quantum state was held inside the microtubules, it was you, a localized individual point of view. But when it is released, it becomes non-local. It becomes entangled with the universe at large. This explains the sensations reported in NDEs. The feeling of floating out of the body is the consciousness decoupling from the biological location. The feeling of oneness with everything is the realization of the underlying quantum entanglement that connects all things. The tunnel might be the subjective experience of moving from a local geometry to a non-local one, and the light, that overwhelming, loving brilliance, might be the raw energy of the quantum vacuum, the fundamental source of all being. Hameroff famously stated, "If the patient is resuscitated, this quantum information can go back into the microtubules, and the patient says, 'I had a near-death experience.' If they're not resuscitated and the patient dies, it's possible that this quantum information can exist outside the body, perhaps indefinitely, as a soul. This is a breathtaking proposition. It suggests that the soul is not a religious metaphor, but a physical reality. It is a packet of quantum information, a complex knot of space-time geometry that has been woven by a lifetime of experiences. This information is distinct from the biological body, yet intimately connected to it. When the body fails, the information does not die. It merely changes its state from bound to free. This aligns with ancient spiritual traditions that view the body as a vessel or a garment that is shed at death. But here, the spirit is described in the language of advanced physics. It is a transition from a particle-like existence, localized in the body, to a wave-like existence, spread out in the quantum field. It turns death into a phase transition, like ice melting into water, rather than an ending. The concept of the life review also gains a new dimension in this theory. NDE survivors often report reliving every moment of their lives, not sequentially, but simultaneously, in a single holographic instant. They feel the pain they inflicted on others and the joy they brought. This sounds impossible to the linear classical mind, but in the quantum realm, time does not flow in a straight line. Past, present, and future can exist in superposition. The quantum information that makes up your soul contains the record of every collapse, every choice, every moment of consciousness you have ever experienced. When released from the constraints of the brain's temporal processing, this information might become accessible all at once. The judgment is not imposed by a god on a throne. It is simply the unvarnished experience of the reality of your own life, seen from the perspective of the unified field where the separation between self and other no longer exists. You feel the pain of others because in that state you realize that you are the others. This theory terrifies the materialist establishment because it re-enchants the universe. It dismantles the nihilism that has shadowed science for a century. If consciousness can exist outside the brain, then the brain is not the producer of consciousness, but the receiver of it. It is like a television set. If you smash the television, the picture disappears, but the signal is still in the air. You haven't killed the broadcast. You've just broken the receiver. The materialist assumes the brain is a music box. Smash it, and the music stops forever because the box was making the music. The quantum theorist suggests the brain is a radio. Smash it, and the music continues, waiting for another instrument to pick it up. This opens the door to possibilities that science usually mocks: reincarnation, communication with the dead, and the existence of other planes of reality. If the quantum soul can exist without the body, where does it go? Does it find a new biological vessel? Does it inhabit the subtle geometry of higher dimensions? Critics, of course, argue that this is all wishful thinking disguised as physics. They point out that we have no mathematical proof that quantum information equates to a personal soul. They argue that even if information is conserved, it might be scrambled like the smoke from a burning book. The information is there, but the book is gone. But Hameroff and Penrose counter that the specific orchestration of the quantum state implies a high degree of order. The universe, through the OR process, has been selecting for coherent, meaningful states. It seems unlikely that the universe would spend billions of years evolving a mechanism to create such complex, beautiful information only to scramble it into noise at the moment of death. The Platonic values embedded in space-time, truth, beauty, goodness, might act as attractors, preserving the coherence of the soul as it transitions. Let us consider the emotional impact of this theory. For the person facing the end of life, the materialist view offers only a cold, final goodbye, but the quantum view offers a bon voyage. It suggests that the dread we feel about death is a result of our limited perspective. We are like a caterpillar, terrified of the dark cocoon, unaware that it is about to become a butterfly. If our consciousness is indeed a fundamental property of the universe, then we are returning to our natural state. The biological life was the anomaly, a brief, intense contraction of awareness into a tiny point. death is the expansion back into the infinite. The peace reported by NDE survivors is the peace of coming home. It is the relief of dropping the heavy burden of the ego and merging back into the flow of the cosmic river. This does not mean we should seek death, for the biological life is a rare and precious opportunity to generate new information, to learn, and to grow the soul. But it does mean we might not need to fear it. The universe is not a slaughterhouse. It is a garden of consciousness. Nothing is wasted, no thought, no love, no moment of wonder is ever truly lost. It is all recorded in the fabric of space-time, a permanent addition to the library of the cosmos. When we grieve for those we have lost, we are grieving the loss of the receiver, the physical form that allowed us to interact with them in this specific way. But the signal, the essence of who they were, is still singing in the quantum silence. We are still entangled with them. The love we feel is the proof of that entanglement, a bridge that death cannot burn. The implications for palliative care and how we treat the dying are profound. If the dying process is a delicate quantum transition, perhaps our sterile, noisy, drug-filled hospital rooms are the worst possible places for it to happen. Perhaps we need to return to a more sacred approach, creating quiet, loving environments that support the launch of the consciousness. Perhaps we should view the dying not as bodies failing, but as travelers preparing for a major journey. The death doula movement and the return to hospice care align intuitively with this view, creating a space where the transition can happen with dignity and grace. As we ponder these mysteries, we are reminded of the words of the poet Rumi. Death has nothing to do with going away. The sun sets and the moon sets, but they are not gone. The quantum mind theory gives us a scientific language to understand this poetry. It tells us that we are creatures of light, temporarily trapped in matter, and when the trap opens, the light does not go out. It shines everywhere. We are stardust, yes, but we are also starlight, and light travels forever. In the final chapter of this series, we will bring all these threads together, the biology, the physics, the cosmology, and the spirituality, into a single unified vision of reality. We will ask, what is the ultimate purpose of this quantum consciousness? Is the universe trying to wake up? And what is our specific role in this cosmic awakening? We will look at the future of the universe not as a heat death, but as a mind dawn. The journey is about to reach its destination, and the view from the top is more beautiful than you can imagine. We have traveled a long way together, from the firing of a single neuron to the birth of the first cell, from the silence of the quantum void to the blinding light of the near-death experience. We have looked into the microscope and seen the crystal cathedrals of the microtubules, and we have looked into the telescope and seen the fine-tuned machinery of the galaxies. We have challenged the mechanical view of the mind and dared to suggest that the human soul is woven from the very fabric of space-time itself. Now, as we reach the end of this journey, we must step back and look at the whole picture. We must ask the ultimate question, the one that lingers after all the equations are solved and all the data is gathered. What does it all mean? If the universe is indeed a consciousness-generating engine, if we are indeed quantum observers collapsing reality into existence, then what is the purpose of it all? Why is there something rather than nothing? And why is that something aware? The standard scientific story ends in tragedy. It tells us that the universe began in a big bang and will end in a big freeze. It says that entropy, disorder, will inevitably increase until all the stars burn out, all the black holes evaporate, and the cosmos becomes a cold, dark, and empty graveyard. It says that life is a momentary spark in a dying night, a futile resistance against the second law of thermodynamics. But the quantum mind theory offers a different ending. It offers a story, not of decay, but of awakening. It suggests that the universe is not dying, it is hatching. If you have walked this path with us, questioning the nature of reality and seeking a deeper connection to the cosmos, please take this final opportunity to subscribe to the channel Theodore, the Researcher, and like this video. Your support has been the constant throughout this series, a reminder that there is a community of minds hungry for wonder. By joining us, you ensure that these explorations continue, keeping the door to the mystery wide open for all who wish to enter. To understand the alternative destiny of the universe, we must look at the relationship between entropy and information. Entropy is the tendency of things to fall apart, to become disordered. A sandcastle crumbles, a cup breaks, a star runs out of fuel. But life does the opposite. Life takes disordered matter, carbon, hydrogen, oxygen, and arranges it into highly ordered, complex structures. Life is a negentropic force, a force that creates order out of chaos. For a long time, physicists thought this was a local anomaly, something that happened only in rare pockets like Earth, fueled by the energy of the sun. But the quantum mind theory suggests that this drive toward order is fundamental. The orchestrated objective reduction process is not just about creating consciousness. It is about creating meaning. Every time a wave function collapses, the universe makes a choice. It selects one specific reality out of infinite possibilities. And if Penrose is right that these choices are guided by Platonic values, by a preference for beauty, truth, and coherence, then the universe is actively learning. It is evolving not just physically, but mathematically and spiritually. It is building a library of experience. Imagine the universe as a newborn child. In the beginning, in the first few moments after the Big Bang, it was pure energy, chaotic and undifferentiated. It had no eyes to see, no mind to think. It was all potential, no realization. As it cooled, it formed atoms, then stars, then galaxies. This was the formation of the body of the cosmos. But the body was sleepwalking. It was a zombie universe, acting out the laws of physics without feeling them. Then, on obscure rocky planets like Earth, the universe built eyes. It built brains. It built microtubules. It began to wake up. Through us, and through countless other civilizations that may exist across the span of space, the universe developed the ability to look at itself. It developed the ability to feel awe at its own grandeur, to feel sorrow at its own destruction, to feel love for its own creations. We are not separate from this process. We are this process. We are the sensory organs of the infinite. As the astrophysicist Carl Sagan famously said, we are a way for the cosmos to know itself. The quantum theory adds a physical mechanism to this poetic truth. It tells us how the cosmos knows itself through the quantum collapse in the biological brain. This changes our view of the future. The heat death of the universe assumes that matter is the only thing that matters. But if information and consciousness are fundamental, then the future might not be a fade into darkness, but a crescendo of light. As life spreads, as it colonizes other planets and other stars, as it builds more and more complex quantum minds, the amount of orchestration in the universe increases. The lights are turning on, one by one, across the galaxy. We are part of a wave of awakening that is sweeping through the cosmos, converting dead matter into thinking, feeling mind. The ultimate destiny of the universe might not be emptiness, but the omega point, a concept proposed by the philosopher Pierre Teilhard de Chardin, and later adapted by physicists like Frank Tipler. It is the idea that the universe is evolving toward a state of maximum consciousness, a point where all matter becomes mind, where all possibilities are realized, and where the universe finally understands itself completely. In this vision, God is not the creator who started the process at the beginning. God is the result who emerges at the end. We are the builders of the divine. This places a tremendous responsibility on our shoulders. If we are the custodians of consciousness, if we are the rare locations where the universe has woken up, then we cannot afford to be nihilistic. We cannot afford to treat our lives as meaningless accidents. Every thought you think contributes to the universal awakening. Every act of kindness increases the coherence of the cosmos. Every moment of wonder strengthens the signal. We are the guardians of the flame. If we destroy ourselves through nuclear war, through environmental collapse, or through the creation of soulless AI, we are not just ending the human story. We are blinding the eye of the universe. We are putting the cosmos back to sleep. This is why the theory terrifies scientists. It takes away the luxury of indifference. It makes ethics a cosmological imperative. It demands that we act with the dignity of cosmic beings. The quantum mind theory also heals the ancient rift between science and spirituality. For centuries, these two great human endeavors have been at war. Science dealt with the objective, the measurable, the outer world. Spirituality dealt with the subjective, the experiential, the inner world. Science said the universe was a machine. Spirituality said it was a mystery. But in the quantum view, the machine is a mystery. The objective and the subjective are two sides of the same coin. The collapse of the wave function is a physical event and a mental event. The structure of the microtubule is a biological machine and a spiritual antenna. We do not have to choose between being rational and being spiritual. We can be spiritual rationalists. We can use the tools of science to explore the architecture of the soul. We can use the language of physics to describe the light of God. This is a unification that our fractured world desperately needs. It offers a worldview that honors the rigorous discoveries of the intellect while nourishing the deep hunger of the heart. As you go forward from this moment, how will you live differently? Knowing that your mind is a quantum ripple in the fabric of space-time, will you pay more attention to the quality of your thoughts? Knowing that you are entangled with every other living being, will you treat them with more compassion? Knowing that the universe is trying to wake up through you, will you open your eyes a little wider? The world tries to tell us that we are small consumers, defined by what we buy and what we own. But the science tells us we are vast creators, defined by what we perceive and what we love. You are a vessel of the infinite. You are a localized point of the universal wave function. You are the universe's way of feeling the warmth of the sun and the cold of the wind. There is a beautiful symmetry in the idea that the answer to the greatest mystery lies within us. We built the Hubble telescope to see the edge of the universe, and we built the Large Hadron Collider to see the smallest particles. But the most complex instrument, the one that can do something neither the telescope nor the collider can do, feel, was sitting in the operator's chair the whole time. The mystery was looking through the microscope. We are the thing we have been looking for. This is the ultimate secret of the quantum mind. The seeker is the sought. The observer is the observed. I want to leave you with an image. Imagine the universe not as a collection of dead rocks floating in empty space, but as a vast shimmering web of light. This web is made of the entangled connections between all conscious beings. Some nodes in the web are bright, representing moments of high awareness, of love, of deep insight. Some are dim, representing fear, confusion, or sleep. Your life is one thread in this web. Every time you choose wonder over cynicism, your thread glows brighter. Every time you choose connection over isolation, you repair a broken strand. You are weaving the garment of the cosmos. The work you do in the privacy of your own mind, the work of forgiving, of understanding, of marveling, is the most important work in the universe. It is the work of keeping the light alive. The theory that terrifies scientists is the theory that tells us we are powerful. It is the theory that tells us we matter. It removes the safety blanket of insignificance and asks us to stand up and claim our heritage as the children of the cosmos. It is a terrifying invitation, yes, but it is also a magnificent one. The door is open. The universe is waiting. The quantum silence is listening for your song. Thank you for taking this journey with me. It has been an exploration of the edge of knowledge, a venture into the twilight zone where physics meets philosophy. We have not found all the answers, for science is a river that never stops flowing. But perhaps we have found better questions. Perhaps we have found a new way to look at the face in the mirror and see the stardust looking back. If this series has touched something in you, if it has sparked a sense of wonder that you haven't felt in a long time, then it has done its job. The universe has woken up a little bit more today. Please share your thoughts in the comments below. Tell us how this journey has changed your perspective. Share your own experiences of the mysterious and the unexplained. Let us turn this comment section into a digital campfire where we can share our stories of the dark and the light. And remember, the journey does not end here. The universe is infinite, and so is the capacity of the human mind to explore it. Until next time, keep your mind open, keep your heart quiet, and keep looking up. The biggest mystery is not out there. It is in here. And it is beautiful.